we need to label one final item on our periodic table, and that is the oxidation numbers. We've identified metals, nonmetals, metalloids. We've identified the valence electrons, and we've utilized those. The last item we need is those oxidation numbers. And for those, if we look right here, this is where those are at. It's in the circles up on top, and so we're going to fill those in right now. We'll start with group 1. Group 1 has an oxidation number of +1, so please go ahead and fill that in on your periodic table. And that now applies to the entire group. So this whole group, if I ask for anything in that group, all of those elements have an oxidation number of +1. Just like on the bottom, the valence number applies to the entire group, this number up on top applies to the whole group. And what that number tells me is that elements in this group are looking to lose 1 electron in order to gain a full outer energy level. Group 2 has a +2. So this entire group from top to bottom, beryllium, magnesium, calcium, strontium, barium, radium, that whole group has an oxidation number of +2. Don't get ahead of me on this one, because the trend isn't quite as straightforward as you'd think. We'll get to the transition metals in a moment. Group 3, +3, meaning group 3 wants to lose 3 electrons. Group 4 could go either direction. Group 4 could lose electrons or gain electrons, so I'll do plus or minus 4. So this just depends on what the element is combining with. So depending on what it combines with, it might gain 4 electrons, it might lose 4 electrons. Group 5 wants to gain 3 electrons. Group 6 wants to gain 2 electrons. Group 7 wants to gain 1 electron. And the noble gases, we'll put a 0 up there, because remember, noble gases don't interact with anything, so they don't have an oxidation number. We're not going to use those for anything in this regard, just because they're not very reactive. Last one, we will use some of the transition metals for these, but they don't follow the nice, neat patterns like the tall columns do. And so what we'll do for transition metals, I'm going to put a note here, and I'd like you to put this same note on your periodic table. Anytime we ask you for an oxidation number of a transition metal, we're going to use the table on the other page. So give yourself that note. We won't use all of the transition metals, just some of the elements that are more common in the world around us, that are more commonly used. And the table on the other page, we haven't used the other page yet, but we'll start to now. I'm going to scroll to that. So I just slide up. Not this table, we'll get there shortly. But if I look at this top table, oxidation numbers of various elements, and you'll notice some of these elements are in the tall columns, but most of these elements are in the short columns. These are the transition metals. Something, for example, if I go back down, if I want the oxidation number for something like chromium. Chromium's a transition metal. I'm going to go up here, and chromium, I find chromium sitting right here. Chromium has an oxidation number of +3. So when we're looking for oxidation numbers, I will either find them sitting up on top, right there, or we just slide to the other page and they're sitting right there. And so that's what we're going to start using as well. That's one of the last things that we'll start using. And then this last table, again, don't worry about that just yet. We will get there shortly.